Joining our conference call today. So we are going to be covering snapshots without penalty and how Maxta beats VSAN Snapshots. So I'd like to take a moment and just cover a couple logistics for the call and also introduce our presenters. So today everybody will be on a listen-only mode, and so we'd like you to present your questions through the chat feature in the tool. At the end of the sessions, we will go ahead and cover all of those questions and finalize any Q&A. So thank you very much again for joining us today. And with that, let me go to introducing our panel speakers. Let me introduce first Howard Marks. He comes to us as a seasoned professional and is very deep in the storage technology. So we're very pleased to have him here talking about the snapshots. And as a follow-on to this, we also have a white paper that people will be able to download and go into additional detail from that. So in follow-up, Kieran will also be joining us. So Kieran is on our Maxta team, responsible for our product marketing and product management.
Thank you very much. So the question we're here to answer today is why we are interested in VM-centric data protection and, in fact, in VM-centric data services anyway. In the past, before we started virtualizing servers, individual workloads ran on physical machines. And even though we had consolidated storage through a fiber channel or iSCSI SAN, one SAN volume or LUN held one workload's data set. So if we used the array features that provide data services like snapshots or replication, we could take a snapshot of that volume and that would directly correspond to a snapshot of the workload whose data that volume held. The advantage of that is it let us create application consistent snapshots because we could, through Windows VSS or a script, quiesce the application, make the data on disk consistent, and then take the snapshot on the storage array. In addition to snapshots, the same concept applies to other data services like replication. When we had a one-to-one relationship between workloads and LUNs, we could use the LUN as a surrogate for the workload. Once we started introducing virtualization, virtualization introduces the I/O blender effect. Because we have more virtual servers than we can manage LUNs. After all, one vSphere cluster has a limit of 255 data stores. So if I have even 500 virtual machines, I, of necessity, have to combine them. And frankly, combining them makes management so much more efficient that, except for occasional mission-critical applications, one LUN now represents multiple VMs, not a single VM. Now, that means that you get crash-consistent as opposed to application-consistent snapshots, and I'll talk more about the difference between those in a second. It also means that your snapshots are going to be larger, because one snapshot now includes the data from multiple VMs. Even if I'm okay with 10 of the 11 VMs in a data store only being crash consistent and the one important one being application consistent, every snapshot is still going to include all of the changes for those 10 less important VMs. That's going to mean it's going to take more disk space. It's going to take more bandwidth for replication. You know, the truth is that taking SAN volume level snapshots in order to protect individual VMs is like swatting flies with a steamroller. Sure, you can be really confident that that fly you rolled over with the steamroller is dead, but it is a mite of overkill. So even within the realm of snapshots, there are significant differences between how different snapshot mechanisms and applications interact. And one of the first and most significant of those is the concept of snapshot consistency. Pretty much any database-driven application today, Oracle, SQL Server, Exchange, MySQL, doesn't really matter, they all work the same way. Those applications buffer updates to their system tables in RAM. And the data that's on the disk is updated asynchronously. So at any given point in time, the data on the disk is not consistent. And what I mean by not consistent is that only part of a transaction may be processed. So if we sold 4 red widgets, the inventory table may have been reduced so it says we no longer have those 4 in stock, but the to ship table might not be updated, so the guys never know to ship them, and those 4 units sit in inventory forever, and even worse, the customer doesn't get them and gets all upset with us. So if we take a crash consistent snapshot, now crash consistent is a euphemism. It means as consistent as the data would be if the server just up and crashed, which means it's inconsistent. It may include those partial transactions, and because of that, when you restart the database engine, it might do an integrity check or a play forward from its transaction logs that could take hours before that database is accessible again. So VSS or scripts can quiesce an application, putting it in hot backup mode, making the data on the disk temporarily consistent so we can take a snapshot. But for most applications, the time limit on that temporarily is measured in seconds. And so you can't quiesce 10 VMs all in the same data store all at the same time, because they're going to take too long to quiesce for the last one to finish before the first one's timer runs out. So the LUN, therefore, has become an obsolete unit of management for storage. Yeah, it served its purpose. It was great when we were bringing Fiber Channel in and we first had shared disks. But today we need the element of abstraction to be more fine-grained. And we'll deal with the fact that that means that there are more objects to manage, either through intelligent tools or automation. And so we want the virtual machine to be the unit by which we allocate storage, by which we measure and manage performance, maybe through storage QoS, and of how we provide data services like snapshots and replication. Now, the VSAN guys have been talking about this. They've been saying one of the things that makes VSAN wonderful is that it does its data services at the VM, not the LUN level. The problem is VSAN does this by relying on the data services that have been built into vSphere for a while. And frankly, vSphere's snapshot mechanism is not terribly efficient. So let's look at what happens when you create snapshots and run VMs in the vSphere environment. So I start off, I have the primary VMDK there, that first purple box. And then I create a snapshot, and that creates a journal or a log file that's the snapshot 1, the second purple box. And then at some point later, I create a second snapshot. And that's the third box. So now, every time an application wants to read data from this VMDK, the vSphere has to look in snapshot 2 and see if the block it's trying to read, the latest copy, is part of snapshot 2. If it's not, then it has to look in snapshot 1. And only if it's not in snapshot 1 will it then look at the primary VMDK and get the data. Now, of course, hopefully these snapshots are relatively small, so most of the I/O is still going to go to the primary VMDK, and we've now turned every read I/O request into 3 read I/O requests. This has a substantial impact on performance, both on writes and on reads, and it also means that when we tell it to delete a snapshot, it has to merge that data back in. It's a complex unwinding, which also creates more disk I/O and more load on the storage system. Modern storage systems use a more sophisticated technique. They have metadata tables to keep track of which logical data block is stored on what other physical data block. And every time there's a read or write, they look up in the table for that one or that volume or that file to see where that logical block maps. When these systems create a snapshot, they simply copy the metadata table that defined the file or volume that you're taking the snapshot of and allow access to this copy as the snapshot. That means that there's no performance impact on reads or writes because every read or write does metadata lookups. It's just looking in a different place in the metadata. It has a very small impact on space. The metadata copy is very small, which also means it happens very quickly with very little disk I/O. And this technology is also required if you're going to do data deduplication, so you'll frequently see the two together. The other advantage is that snapshots are independent objects, so regardless of how many snapshots you take or whether you take multiple snapshots from the volume itself or you take father, son, grandson, great-grandson type snapshots to keep track of all of the states of a machine over time, there's no difference in the performance impact between the first snapshot and the 20th. So now imagine that we take this metadata snapshot technology and, like Maxta's storage platform, apply it not to volumes but to virtual machines, or in fact to individual VMDKs. So this means that we can now use snapshots as an integral part of our data protection scheme. We can say, I'm going to take an hourly snapshot of the ERP system SQL server so that if that database ever gets corrupted, I can revert and have a recovery point objective of just 1 hour. And I'll keep those for a day or two. It allows you to, because the snapshots are small, replicate that data for disaster recovery purposes. Now remember, a snapshot is just a read-only copy of the metadata table that defined a file or a VM. And if we just take the read-only tag off of it, it becomes a clone. So now cloning is the same process as creating snapshots. They're still independent because there's very little data to be copied. These snapshots and clones can be made very quickly. In fact, many of the modern systems that do this can create clones faster in, say, a VDI environment than vCenter can update its database to know that those machines are there. The cloned VMs take almost no disk space, almost no system bandwidth to create. And because now we're only storing one copy of any given piece of data, when that data becomes hot enough to move into the layer, it only moves in there once. And so there may have been 100 copies of winsock.dll. No individual one of them was very hot, but if it was one common copy, it would be moved up into Flash. That makes the Flash layer more effective and generally improves performance. So before I hand off to Kieran, I want to talk 1 second about the Maxta storage platform. The Maxta storage platform is a software-only server SAN product. And by server SAN, that means that it takes flash and spinning disk resources from multiple servers, creates a single hybrid storage pool across all of that storage. Maxta storage platform runs as a VM under ESXi. They provide per VM data services like snapshots and clones. It also provides data reduction through both compression and deduplication. Unlike most of the other server SAN products, they provide enhanced data integrity by using hashes and scrubbing to make sure that data remains on the disk in the way it's supposed to. They do N-way mirroring, and in addition to N-way mirroring across nodes, they also do N-way mirroring within the node so that you can have local and cluster level data protection. I want to talk for 1 second about deduplication in the VM world. Metadata clones aren't quite deduplication. They're really a duplicate avoidance. Once the VMs are created, like linked clones, they diverge. And so, on Patch Tuesday, you still end up with 100 copies of the patches. The world of virtual machines, VMland, however, especially if you're doing VDI, presents a duplicate-rich environment that deduplicates very well. One of my favorite ways to do VDI is to use a storage system that does deduplication and use full clones so I can have really persistent VDI that looks and feels to the users like they still had desktops. Deduplication, like we talked about a second ago with the cloning, increases the effective size of the flash layer and can that way improve performance. So I'm now going to turn things over to Kieran S. so that he can show us the Maxta platform and just how wonderful it really is.
Okay, thanks, Howard. It was a very good introduction on the Maxta platform from Howard. Let's get into a little more details on how we do things, and then we'll also do a quick demo of how our snapshot works, and also how the VSAN snapshots, which is what Howard talked about, will show what's the impact of performance and so on when users take a VSAN snapshot. In other words, a VMware vSphere snapshot, which is close to what a VSAN does. To elaborate on what Howard talked about, in this example, I'm just going to go over the architectural overview of Maxta storage platform so that people who are new to Maxta would get a good understanding of the product. In this example, let's assume that there are all these big blue boxes represents an ESX host. And as we all know, we'll have the hypervisor installed on each one of the hosts. The Maxta instance will be running as a virtual machine on each one of those physical ESX hosts. And the role of these Maxta instances is to aggregate all the storage resources across the nodes within that cluster, create a storage pool, and present it back to ESX. And the presentation is done via an NFS protocol, and it also creates a global namespace across all the nodes in that cluster. So now what's some of the benefits that what customers would see with this approach? Number one, since we present it as a global namespace, it's analogous to any other storage array presenting a LUN or a volume. So the customer can now have the same user model of a storage array without the storage array. So essentially, you can eliminate the need for a storage array. In addition to that, what Maxta enables is for all the data services that Maxta supports, it's all done at a VM level granularity. So what's this benefit for the customer if we do this at a VM level? As initially Howard talked about, right, one of the key things is to make sure that when the user wants to take a snapshot, it's a snapshot of a virtual machine and not a LUN. So that's essentially what Maxta enables. And the end user benefit is it will dramatically simplify your full IT operations. When users are dealing with a virtual machine, which is the logical entity of management, all the way from your compute to your storage, you can use the same level of granularity. And as Howard mentioned, we do a lot of strong checksums to deliver the data integrity aspect within the product. And the product is also optimized to take advantage of SSDs or flash for performance and spinning disks for capacity. To demonstrate that, let's just walk through a process of a write operation. So when a write operation happens or an update, what we essentially do is write the data onto an SSD on the local server. We always make copy of the data onto at least one server and then only acknowledge the write back to the application, delivering the data protection that is required. And when we write data onto these SSDs, we always write it sequentially. This will also enable to make sure that the SSD's life is prolonged because we don't rewrite the same data blocks over and over, same cell on the SSD over and over, diminishing the lifespan of the SSD. And in addition to it, we also have this notion of VM locality. We always co-locate the VM and the data to be on the same server so that we can deliver the best performance, not only IOPS, but also deliver the lower latencies that is required by most of the applications. In addition to all these, just to talk a little bit about the flexibility of deployment, you can have, even within the same cluster, I can dedicate some of the nodes within that cluster to be used for computational purposes only, and the storage capacity will be utilized from the other nodes within that cluster. This would mean that I can now have the flexibility of having storage nodes or converged compute and storage nodes, and as well as just compute-only nodes, right? So now it will, in a lot of scenarios wherein you just need additional CPU and memory resources and have enough storage resources already, now you can go provision either a small 1U box or so to get the computational resources required. And also it provides a layer of investment protection with the Maxta platform to our existing customers. We all know storage in a storage environment, it's not possible to do a rip and replace, right? You always have your existing storage ecosystem. And the benefit of Maxta is to play along very well with it and coexist with it, not only from a storage, but also from a server perspective. Maxta would seamlessly be installed on the existing nodes of the cluster, and you get a shared storage, and you can use it alongside with any of the other resources that you currently have. So that's essentially a high-level overview of the Maxta storage platform. So a lot more information is available on our website. So and if you have any questions, you can always ask during the session at the later point. What I would do is we'll have an IO meter that's running, which will essentially show you the performance. And while the IO meter is running, we will take a Maxta snapshot and show that there is no degradation in performance. And once we observe that, let's then go ahead and take a VMware snapshot, which is same as what VMware VSAN Snapshot would be, and see the impact of taking a snapshot, and you will see that there will be significant performance degradation. If time permits, we can also go take a look at to see if we can show how we create Maxta clones and the functionality of it, which essentially does not take up any space, and also called as zero-copy clones. With that, let me switch over to the product demo. Let me minimize the screen. Here I have my vCenter running, and on one of the virtual machines, I also have IO meter running, which is essentially showing you the performance without any snapshots so far. So if I go back to the virtual center, and this is the virtual machine, I'm going to just go right-click on it, take a Maxta snapshot, and here we'll just give it a test Maxta snap. Okay, and just a test, and say proceed. And once this is done, you will see that the snapshot creation is also complete. It's in effect almost instantaneous. And now if I go back, as you can see, the performance, there is no impact. In fact, it's performing the same or even better than what it was. I can even go ahead and take another snapshot and demonstrate the same to say that there is no impact irrespective of the number of snapshots that you take. And I'm going to call this test VM snap 2 and proceed. And once this is done, you can see here that snapshot completion is already done. And if I go back, as you can see here, it's pretty much increasing, right? There's no degradation in performance at all. And I can take 10 of these again, and even with that, there will be no degradation. Now let's go back and take a VMware snapshot and see what happens to the performance. So let me right-click on it, same location, go take a VMware snapshot, which is same as what VSAN would do. Test VMware snap. I'm going to call it test. And I will not snapshot the virtual memory or virtual machine's memory. Say OK. Snapshot is in progress. As you can see, even taking without memory footprint is still considerably longer. I mean, yeah, it still probably completes within a minute, but still it's considerably longer than what a Maxta snapshot generally takes. It's not done yet. It's almost, should almost be there. Okay, so let's go back here and see how the performance is doing. It's almost paused at this time. It's trying to take a snapshot and it's working on it. And as you can see here, for a minute, it's done. The VM looks like it's doing something, and we don't have the IO meter going through. And it's still taking a while to create a VMware snapshot. I'm just waiting to make sure that the VMware snapshot creation is complete. Still taking a while. As you can see here, now it started, but as you can see, the performance is going down. From almost close to 12,000, it's rapidly decreasing. It's like a free fall, right? So in a minute, we should see that the snapshot creation would be complete. It's taking considerably longer than what I would expect. Okay, now it's done. And now let's go back to the IO meter and see how that's behaving. As you can see, it's almost going down from the time we took a snapshot, and it's reducing by the second, right? So if you leave this for a couple of minutes, it will even drop down by 40 to 50%, sometimes even 80%, depending upon how many snapshots you would take and so on. It reduces quite a bit. Already we have seen 20% degradation, and it just took a snapshot, right? So if I wait for another 10 minutes or so, you will see that it will further decrease. As you can see here, it dropped down to 11,000 from 12,000, so it's almost a 10% drop now. So essentially, this demonstrates that there is a performance penalty of taking a snapshot. And now, if I take another one, it would be much worse. If I go take another snapshot, same, this is the VMware snapshot, test VM snap 2. And I'm not going to snap the virtual memory, test 2. Okay, go ahead and take a snapshot. As you can see here, it not only takes time to create these snapshots, it will see here for a second, it stuns the I/O meter, meaning it's coaxing the VM or so, and then it's taking up all the resources to take a snapshot. Essentially, that's what I wanted to demonstrate to show that VMware's VSAN is more of a checkbox entity, but in all production deployments, that's not something that users can really depend upon for their short-term data recovery and data protection purposes. With that, let me go back to our presentation and move over to the summary of the snapshots and data protection slide, which generally highlights all the things that we just talked about. To start off with, if you look at a high level from Maxta point of view, we call them time, performance, and capacity efficient. But going one by one, if you look at the performance, we saw negligible performance impact, or probably it was actually increasing in performance. And from VSAN perspective, we have seen that the performance to degrade all the way from 40 to 80%. If you leave it running for 15 to 20 minutes, you will see this. From a deletion point of view, which I did not show, but essentially if with a Maxta snapshot, it takes sub-seconds to delete them, but on a VMware, depending upon how much I/O is being written, it can take minutes to hours for deleting a snapshot. And during this deletion process, also you will see significant degradation in performance. And when it comes to capacity efficiencies, we don't take up any space when we create them. It's very high. It's probably few kilobytes just for the metadata and so on. But when it comes to VMware, it takes up some capacity when you take snapshots. But when you do clones, for example, it's almost the number of clones to the number of amount of capacity. It's detrimental to the overall capacity utilization. As you can see here, it's almost a multiplying factor of the number of VMs and the number of amount of capacity on each one of those VMs. So essentially, that concludes our presentation on why Maxta snapshots are significantly superior than VSAN's snapshot technology, and also in addition to the clones technology. And I'll hand it over to Carolyn for the Q&A session.
Great. Thank you both Howard and Kieran for the presentations there. We did have a few questions that have come in from the audience as we've worked through the presentations. Feel free to submit additional questions if you'd like. Just going to the first question. Let's see. How many snapshots and clones can I create?
So when we talk about the Maxta platform, there is literally no limit. You can take thousands of snapshots without any degradation to performance or time that it takes to create them or even capacity. So we have tested to closer to between 5,000 to 10,000 snapshots on a particular virtual machine. So literally there is no limit.
Okay. Next question here, it's a two-part question. How is the Maxta performance compared to VSAN? And does the fact that VSAN is in the kernel versus user space give it an advantage?
Sure, I can take the question, and then Howard, you can also add your comments. I mean, the key VMware always says that, hey, the VSAN is part of the VMware's kernel, but essentially what we see are two folds here. One is, although, I mean, technology-wise, there might be some benefit by being in the kernel, but on a practical basis, there is absolutely no benefit because today, especially with the CPU being so powerful and the context switches that happens within the kernel, is not a factor in terms of reducing the performance of the overall system. Your disk subsystem, your networking subsystems probably would be far more impacted sooner than your CPU resources or from the effect of context switching. The second aspect to it is also, in fact, it's much more of a deterrent because since it's in the kernel, it has to be always released along with other versions or the major versions of VMware's vSphere capability, which essentially prolongs the release cycle from an end customer point of view. From an end customer point of view, we believe that having it in the user space is far superior, especially because of being able to release sooner and also being able to have not much of an impact just because it's in the kernel. The other key benefit that I also think is in terms of being able to support other hypervisors, right? If it's in the kernel, it becomes very hard to support any other hypervisors because now it has to be totally implemented new because the kernel is always new for every hypervisor. Running it in a user space provides the flexibility of supporting other hypervisors much easier and much easily than being in the kernel.
Okay. From where I sit, there is definitely a small latency advantage to operating in the kernel, but that's similar to saying that when I run SQL Server on bare metal, it runs faster than if I run it as a VM. There's a maybe at most a 2 or 3% or 100 microseconds of latency difference, but the differences between implementations are much greater than the differences between architectures. A well-done system in user space will outperform a mediocre system running in the kernel. And certainly if I were a storage, if I were out creating such a product, as Kieran said, the market is much broader if you run in user space because you can support Hyper-V and KVM much more easily than if you're running in the vSphere kernel, which there aren't really public APIs to do, so it's not an option for anyone else but VMware. Yeah, I would look at the product much more holistically rather than worry about that. It's kind of like Homer Simpson telling the car salesman that he wanted rack and peanut steering. If you don't really understand exactly why you want it to run in the kernel, knowing that it's an advantage and using that as a decision factor rather than simply going, how fast is it? And determining what set of features you want doesn't make any sense.
Great, thank you. We'll move on. We've got a couple more questions here. Where do you store the metadata table? Is it in RAM? If yes, how much of RAM does your solution occupy?
Yeah, sure. I can take that question. Yes, it is stored in RAM. I mean, as we said, Maxta runs as a virtual machine, and then for each of the virtual machines that is deployed on an ESX host, we put a reservation on both CPU as well as memory. We reserve 4 vCPUs, and we reserve 8 gigs of memory per Maxta virtual machine that's deployed within that cluster.
Read that as per host.
Yes, per host.
Okay, next question is, could you briefly cover how the metadata is protected and how it references the snapshot?
Sure. As we all know, metadata is a set of pointers, in other words, to where the new data is residing. So metadata is just an indication of where to go look for the new data, and that's how snapshot is referenced. Say if a new data block is written. Oh, the other aspect that I would like to highlight here is we never overwrite the same data block at any point in time. We always write it in a new location. So now when a new write comes in or an update to an existing write comes in, we will first write it in the new location, let's say a new offset from a block perspective. And now this offset has to be updated in the metadata table to say now to read this block, you need to go to this offset to refer to this data. And that's what we store in the metadata. We write the data in a new location, update the metadata with the offset of where the data was written. That's how the snapshot or the new data is referred to in a snapshot. So now how is this metadata protected? We make multiple copies of metadata to retain within that cluster so that in case if a node fails or so on, it can be easily accessed across the different nodes within that cluster. In addition to it, we also make copies of it within that node itself or within the different data blocks. It's more like a super block, in other words. If people who are familiar with the Unix implementation, it's more like a super block wherein you have multiple copies of the same information across the file system, and that's how we protect the metadata so that customers still have access to the data even if a drive, even if a node or any of those fail.
Other question, is there a tool for creating policies or schedule management?
Sure. We have a scheduler within the Maxta user interface that users can go schedule a snapshot. Essentially, the way customers have been using that is they would set a policy to say, here is how frequently I would like to take a snapshot of a particular virtual machine. And they would also set the retention policy to say, here is how long I want to retain this particular snapshot. It could be, I want to keep it for 15 days, I want to keep it for a week, depending upon what's the organization's policy. They can set it on a per VM level granularity. That's the key here, right? You always set it on a per VM so that if there are certain virtual machines that are more important than the others, you can have a different schedule for those particular virtual machines.
Okay. All right. I think on the number of questions coming in, unless there are any final questions, that we've gone through the questions in the queue. Let me take a moment. Howard, are there any summary comments that you'd like to provide before we close off the call? And then I'll go to Kieran next.
Well, I think that it's important for us to realize that we need to move our concepts in the market forward and remove the LUN as the unit of abstraction and move instead to the virtual machine.
Exactly. I second that. So definitely, if you need more information, visit our website, give us a call. We'll be very happy to talk to you guys.
Thank you for joining us for today's webinar. We appreciate your time. As I mentioned before, we will also have a white paper that will be summarizing the discussion points from this call that Howard helped us create. So we will have that posted up on our website today. So feel free to go ahead and go online, or you can contact your sales rep if you prefer to gather it that way. Again, thanks for tuning in with us today. We appreciate your time. Have a great day.
Thank you.
Thank you.